Hello, everyone. Welcome to this fascinating world of Python iterators. They are super useful because Python iterators allow you to iterate between iterables. Iterables are objects in Python that you can iterate over, such as lists, strings, or dictionaries, for example. If you want to go into a simple example of Python iterator is that you can take a list. Let's say I have a list of 1, 2, 3, for example, and I can say for I in each item, and I want to print I. So if I run this, you can see that it goes through the list, it prints 1, 2, and then 3. Iterables are essentially objects that have an associated iter method. So we can take that same list that we had earlier and we can look at the iter method and you'll see that we indeed have a list iterator in this case. So we can have a built-in function in order to obtain that iterator from an object. And this is the iter function, 1, 2, 1, 2, 3. And this is how you obtain the iterator from an object. Under the hood, the for loop, what it does is it applies the iter function that you're seeing here to create an iterator, and then it iterates over that object. Okay, so that's the complex and too hard to understand way of using iterator, but is the iterator in Python is just an object that you can iterate over a collection of data. And it allows you to return the data line by line. Okay, so for example, what is the difference between an iterable and an iterator? So we have my string. This is an iterable. So we can iterate over each letter of the string. The iterator, instead, what it is that it is the iter of that my string. So now I have the iterable and the iterator. I can then take that iterator and iterate over one line at the time. So we can use the next function to just iterate, and then I run it again, and then it's E, and then it's L, and then it's L, and then it's O, and then it's over, stop iteration. Um, this is super useful to save resources, computing resources, because you just don't load everything, you just load one line at a time. So then we have this iteration error that we have just seen. You can also iterate over all the values of an iterator using the star operator. The star operator is often called the splat operators, but what it does is that it unpacks all the elements of an iterator or iterables. So let's take again my string and my iterator, and we want to just go through each of them. We can say print splat operator and do iterator. And as you see, we just unpacked it all at once. But one thing to consider is that you cannot do it multiple times. So here, nothing happens because you have already unpacked it. So if you want to do it again, you would need to redefine these. If you want to unpack this into a list, then we can take our earlier example and just do list iterator. And then it just unpacks everything and returns it as a list. You can also unpack it as a tuple, for example. So we can say tuple iterator, and you impact it into tuples instead. So it's super useful here to learn about that. Then you can also just open a file with open, and you would say my file text. In this case, uh, let me copy the full path. to the file, but I can have my file.txt, and in this case, let's make this as read and then as f. And then I have this unpacking, and then I can do iterator equals iter f. And then it's interesting because what I can do here is I can just read the first line of my object, saving me a ton of bandwidth. And here I'm just printing hello world. There are built-in operators in Python that can help you work with iterators. You have enumerate and zip uh, uh, iterators. So what enumerates does is that it will yield an index and a value pair. So it will put an index for each value of an item, and zip will combine two iterable. So in order to use enumerate, you just have your list, and let's say I have a list. It's called ABC, and what I want to do is I want to return for I and V in enumerate. So enumerate list, then I have print I and V. So as you see, enumerate just is an iterator that allows you to create an index 0, 1, 2 for each of the values of my list. I could have used next as well with enumerate lists, and you see that it will just put 0, then yeah, it will just put 0A. There's a useful function too that you can do is that you can use the list operator on the enumerate object that we had. As you can see, it returns a list of tuple, but what I want to do is I want to start at tree instead. And where's my error? I have a parenthesis missing. Uh, Oh no, okay, there it is. I have the parenthesis missing, and then you see I have started at 3, 4, 5 instead of starting at 0. The zip operator is a little bit more interesting. Is let's say I have a tuple and a list. Both of them are iterables, and I want to join them together, so I can do zip equals zip and do list tup, and then I return my list zip. So here, let's say I don't return my list zip. You'll see what it returns is a zip object. So you want to do that list zipped. So you can unpack all the values into the list, and you can see that it has matched A to dog, B to cat, and C to bird. You can also use that as the star operator. So you can use the zipped and print unpack zipped, and that essentially prints it. Similar, it prints the unpacked list. Now let's go into Python generators. Python generators, they are a way to create iterators in a more concise and memory efficient manner. So let's introduce the yield keyword in Python. The yield keyword is used inside a function to produce values and pause the execution. So what it does is that it shows the value, it pauses, it iterates over the next, it pauses again and again. In order to create a generator function, we would just do def and simple generator, and we would say yield 1, yield 2, yield 3. So there are no limit as to the number of yields that you want to do, but you can just say, okay, I have my simple generator and it's here. So now I've created a generator object. If I want to do a generator object, I would just use it example similar as what I just did with the generator object. So I can say, okay, if I just print next gen, then I run this 1, and then 2, and then again 3. and then overall it would stop iteration. So we have created our own generator object to iterate over. It is very interesting because then you can build your infinite sequence. So you can say infinite sequence, where generally we would say while true, num equals 0, and we would say while true, num plus equal 1. If I run this, it will always be true, and it will iterate over and just print 1, 2, 3 until my program crash. Uh, but if I use a generator object, I can use yield and return num. And this is where it's really interesting because printing infinite value has potentially infinite computing resources required. But if I just use this to as a generator, then I can just print next gen. And in this case, I go from printing infinite uh, amount. I go from infinite amount um, of computing power to no potentially at all problem because I can print each item one at a time. I could add as many as I want, but it's it, the computing resources are very low because this truly shows you the potential and power of a generator object. If you want to create a generator object, you can do it without yield. And then what you would do is you just use the parentheses. If you use the parentheses, you can say x for x in range 5. So it really looks like a list comprehension, but in this case, it is truly a generator object. A list comprehension would be like this, right? For those who didn't know, this is a list comprehension. It just returns it, and parenthesis instead of uh, bracket is a generator object. So then you can just loop over the generator and say for x in generator, print x. So why should you use generators in Python? It is super useful when you work with extremely large data set. If I have a file with 10 billion rows, you might not want to load those 10 billion rows straight up in your computer. Maybe you want to load just 10 rows instead. So let's see how generators are efficient. Let's take time, and I'm gonna time the execution here. I'm going to do a list comprehension. This x for x in range 10, 9. Okay, that's a very large operation, and I just want to pick up the first item of a very large list. If I run this, uh, okay, I want to time it instead of time. So you can see it takes a super long time to run. If instead of doing this, I want to execute and I use a generator, I have time to write a function. See, it just took 16 seconds to run. Sorry for not having this, but if I take my generator for x in range 10, 9, you can see it's a similar thing, but in this case, I'm doing a generator instead of just a list. And I just want to pick up the next gen. I run this, you can see 0.0 second. It loaded instantly because I'm just trying to pick the first object of the generator. So it's super useful to use in context of large scale. If you want to create your own iterator, it can be complex. I will not go into the depth of Python classes, but I'm just going to show us an example. If you don't know how this works, I strongly urge you to take a class on object-oriented programming. But in this case, I'm going to create a class of positive integers, and I will initialize this as def init and self. And I will just take the self current equal 1. So I want to have only positive numbers with this class. I will create the iter method here for my class. Um, def iter self and return self. And then I want to create the next. So if you create your own iterator, you need to be able to define the next function. So remember, I told you right at the beginning that an iterator has the iter method. So you have to create that iter method, and you need to define the next function so that we can use it later. So we could say self, and we say, okay, what happens if we do self? We say if self current is less than equal to 5, result equals self dot current self dot current, and then I will increment by 1. So to return the result, else, remember when we got to the end of our loop, we need to raise stop iteration. So in this case, if you don't know what this means, you can look at our example on try and accept on my tutorial and try and accept. I teach you how to raise your own exception, but that's essentially what it does. So when you reach the end of the loop, then you will stop iteration. So essentially, I'm saying print everything until it's 5. So then those are comments. And then if you want to use this, you can create your numbers, iterator, and then you can say positive integers. So here you have your objects. I've created that class. I've created, initialized my class. I've created the iter method. I've created the next method, and I've raised the exception if I reach the end. So then I can just do next. I can just print next. No. So let's just run this in a separate section so it doesn't instantiate every time, but you can see that every time I run this, I get to the end. Oh, and yes, I've just stopped the iteration. If I wanted to come back, I would need to uh, instantiate my class again. And instead of doing next, I can just say for num in number iterator, and then I would just print num. And you can see that it works as an iterator. So this was the end of our tutorials on Python iterator. Make sure that you like and subscribe this channel or follow me on my blog where there's a lot of resources for Python for beginners. Thank you very much. See you next time.